The presentation will be explaining how maxima and minima may be determined using differentiation. We will cover a brief introduction on differentiation, first-order differentiation, second-order differentiation, stationary points, and some applications.
Differentiation can be defined as the gradient or slope at a point on a curve. Therefore, if we draw tangents at different points as shown in the diagram and determine the gradient of these tangents, these would be equivalent to the derivative at the particular point. Drawing a tangent to a curve manually at different points may be very tedious and not very accurate. Differentiation is a quick and accurate algebraic method to determine the gradient at different points on any curve, that is, the rate at which the slope is changing. We will now move on to differentiation of algebraic functions using the general rule. If y is equals to ax to the power of n, therefore, the y by the x is equals to an x to the power of n minus 1, which is obtained by multiplying the power by the coefficients of x and subtracting the power by 1. A and n are any constants, and the y by the x denotes the derivative of y with respect to x. In general, the derivative of a constant function is always 0, since the rate of change of something which never changes is always 0. Let us consider the first example. If y is equals to 5x to the power of 7, in this case a is 5 and n is 7, therefore using the general rule, that is, multiplying the power by the coefficient of x and subtracting 1 from the power, we obtain the y by the x, which is equal to 35x to the power of 6. Considering a second example, if y is equals to 3x to the power of 4 plus 5, then the y by the x is equal to 12x cubed, which is the derivative of 3x to the power of 4, plus 0, which is the derivative of 5. Note that the derivative of 5 is 0 since 5 is a constant. We will now move on to some applications. If distance x is represented as a function of time t, that is, x is equal to f of t, then the velocity v, which is the rate of change of distance with time, is denoted by v is equals to dx by dt. Consider the following example. If distance x meters moved by a car at time t seconds is given by 3t cubed minus 2t squared plus 4t minus 1, determine the velocity when t equals 0 seconds and t equals 1.5 seconds. If x is given by this equation, then v is equals to dx by dt, which is equals to 90 squared minus 40 plus 4. Therefore, when t equals 0, dx by dt is equals to 4 meters per second, which is obtained by simply substituting 0 for t. Similarly, when t is equal to 1.5 seconds, dx by dt is equals to 18.25 meters per second, which is obtained by substituting 1.5 seconds for t. The following table includes some standard derivatives. The derivative of ax to the power of n, as already discussed, is equals to an x to the power of n minus 1. The derivative of sine ax is a cosine ax. The derivative of cosine ax is given by minus a sine ax. The derivative of e to the ax is ae to the ax. and the derivative of ln ax is given by 1 on x. A and n are any constants. We shall now discuss the second derivatives, referring to the previous example where x is given by this cubic equation. As already explained, if this is differentiated once, we obtain the velocity dx by dt. If this function is differentiated a second time, we obtain what is known as the second derivative. This is denoted by d2x by dt squared. This is defined as the rate of increase of speed with respect to time, which is in fact the acceleration a. In order to determine the acceleration of the above function, we need to obtain the second derivative. If x is equal to f of t and v is equals to dx by dt, therefore a is equals to dv by dt, which is equal to d2x on dt squared, and this is equals to 18t minus 4. Consider the following example. Determine the second derivative of 2x to the power of 5 minus 4x cubed plus 3x minus 5. The first derivative is obtained by differentiating each term individually as already mentioned. By differentiating each term a second time, we obtain the second derivative. Therefore, d2y by dx squared is equals to 40x cubed minus 24x. Moving on to stationary points. A point on a curve at which the gradient is 0, that is, where the y by dx is equals to 0, is called a stationary point, also known as the turning point. At a stationary point, the tangent to the curve is horizontal, and the curve is said to be flat. There are two types of stationary points. These are the maximum and the minimum. Considering the maximum turning point. In this case, the gradient of the curve is positive to the left of point P. To the right of point P, the gradient of the curve is negative. Considering the minimum turning point. In this case, the gradient of the curve is negative to the left of point P. To the right of point P, the gradient of the curve is positive. From these, one may conclude that for a maximum turning point, d2y by dx squared is smaller than 0. For a minimum turning point, d2y by dx squared is greater than 0.